Yep.
Cool. So, fusion reactions, these are like the opposite in some ways to fission reactions, but they're the same in some ways as fission reactions. So fusion reactions, what we're doing is we're fusing together two really small nuclei to make a slightly larger nuclei. So that's the opposite to a fission reaction in the sense that we had a big nucleus that we were splitting into two smaller nuclei. In this case we're doing the opposite, we're getting small nuclei and putting them together. The thing that's the same is that the product nucleus that we're making is more stable than the original parent nuclei, and therefore we are, if we find the mass of our parent nuclei and the mass of the products, then the products have a slightly smaller mass than the original nuclei, the reactants, and so that change in mass is converted to energy. And there's kind of the cycles of fusion reactions that happen in places like the sun. This is kind of what's happening in the sun. So things like deuterium and deuterium colliding together to make helium-3 and a neutron, or deuterium and deuterium colliding together to make hydrogen-3, tritium, and another hydrogen, or tritium, the same one that was formed here, because remember that tritium has a half-life of about 12 years, and so if we're not constantly forming it, there's going to be none left quite quickly. And so tritium plus deuterium to make helium, normal helium-4, and a spare neutron, or that helium-3, that one that we produced up here, might collide with the deuterium to produce helium-4 and a spare hydrogen. So they're kind of the cycles that are occurring. So these first two don't produce that much energy, but they produce the helium-3 and the hydrogen-3, the tritium, that we need for these bottom two, which produce a whole lot more energy. But it's these cycles of reactions that are happening on the sun, as the sun burns hydrogen to make helium. It's kind of how the sun makes energy. And we would love to be able to do fusion reactions on Earth because the products are not radioactive. Like we're using hydrogen, which we can get from water, and we're producing helium, which is a non-reactive, non-radioactive gas. So we've got no concerns about radioactivity in terms of fusion reactions, whereas the fission ones, all of the pieces that have been in our reactor are going to be bombarded by neutrons, and so they're all going to be really radioactive. So we don't like fission reactions because of the radioactivity. However, fusion comes with a few problems, and that is that these hydrogen nuclei, they've both got positive charges, and so if we want to get a hydrogen nucleus to collide with another hydrogen nucleus, we've got to have them zooming together really fast, because there's going to be electrostatic repulsion, we call it Coulomb repulsion, between those two nuclei, and we have to get them so that they're touching in order for them to actually react and form a new, larger nucleus. And so that's the temperature, the really high temperature inside the sun is what gives these particles, the reactants, enough energy to have that kinetic energy to crash into each other. And the sun's really big, right? So lots of gravity, and so that holds them close enough. So it's not enough just for them to be moving really fast, and it's not enough for them to be held really close together. We have to have them moving really fast and be held really close together. And so our attempts on Earth to make fusion happen are having to solve those two problems. Like we have to find containers to hold hydrogen that's moving kind of at the speed that it would be if it were on the sun, so it's glowing that hot. So something that's not going to melt when it's exposed to those temperatures, and will contain them in a small enough volume at a high enough pressure that they will actually react. And so we've got in laboratories on Earth fusion reactions to happen for a few seconds. That's kind of where we're at the moment. Once we solve this problem, we're going to have a lot of energy, and we won't have any energy worries